Hi there and welcome to our next video on the electronic structure. In this video we're going to be having a look at the groups and periods in the periodic table. We're going to have a look at some of the rules you need to know of the electron shells, and we're going to have a look at some examples. So let's get started. Groups and periods. So the groups go down the periodic table and there are 8 groups in total. The periods go across and in total there are 7 periods. The groups which go down tell you the number of electrons the atom has in its outer shell, and the periods tell you how many electron shells there are in the atom. So visually looking at this, the periodic table, the groups go down. As you can see, there's group 1, group 2, group 3, 4, 5, 6, 7 and 8, sometimes known as the group 0. Periods go across, and as you can see, there's period 1, 2, 3, 4, 5, 6, 7. So now we're going to have a look at some of the electron shell rules. So in the center of an atom we have the nucleus, and in the nucleus there are protons and neutrons. So we have protons and we have neutrons. Electron shells orbit the nucleus. So over here I'm drawing the electron shells. The first electron shell can hold 2 electrons. I've shown that over here. The second and third electron shells both hold 8 electrons, and you can draw them like this. Both of these shells hold 8 electrons, and now we're going to put that into action and look at some examples. So we might be asked a question to draw the electronic structure of boron. First we have to find boron on the periodic table. It's over here in group 3. So just by looking at the position of boron, it's in group 3, so we know that it's going to have 3 electrons in its outer shell, and it's in period 2, so we know that there's going to be 2 electron shells. So over here, let's draw the nucleus in the center of the atom, and the electron shells orbit the nucleus. So the first electron shell, remember it holds 2 electrons, so we draw 2 electrons like this. And how many electrons do we have left? We have 3 electrons left, and we can put that in our next electron shell. We have 3 left, so we just draw those electrons in. If you wanted to, we can also do the protons and neutrons in the nucleus. So it will have 5 protons, 1, 2, 3, 4, 5, and it will have 6 neutrons. 11 subtract 5 is 6, so we can draw 6 neutrons. And that is the electronic structure of boron. Now let's try another one, sodium. Let's find sodium on the periodic table. It's over here, sodium. So by looking at it, it's in group 1, so it has 1 electron in its outer shell, and it's in period 3, so it has 3 electron shells. So let's start off by drawing the nucleus, and our first electron shell, this holds 2 electrons, so we can draw them in. And now we have 9 electrons left to draw. So let's get our next shell. 1, 2, 3, 4, 5, 6, 7, 8. But we've got a problem, we need 9. So this means we need to draw another electron shell, because we still have remaining electrons, and we can draw that last one onto here. And that is the electronic structure of sodium. Our final example we're looking at is neon. In the periodic table, neon is over here. So neon is in group 0, and it's in period 2. So we've got a bit of confusion here. Group 0, how many electrons does it have in its outer shell? So sometimes group 0 is known as the group 8 elements. So group 8 has 8 electrons in its outer shell. So that means it has a full outer shell. So let's write over here the nucleus, then our first electron shell, which holds 2 electrons. And now we have 8 electrons left, so we get our next electron shell and we draw our remaining 8 electrons on 1 2 3 4 5 6 7 8, and like that we have our full outer shell. And this is a reason why the group 8 elements are very less reactive. It's because they don't need to react to gain a full outer shell, as they already have one. In the description box below there's a link to a quiz which you can have a go at, but for now that is it for this video. Thanks for watching. I hope you liked it, and one last thing, please subscribe and hit the like button.